So lately I noticed a lot of animosity between Rust and C developers for some reason. My comments are full of hot takes like this, which I love and I encourage, so thank you so much for your feedback. But that's when I noticed that probably there was something bigger going on and I had to look into it. And here's what I found. It turns out that there's a huge battle within the Linux kernel between C and Rust developers. Okay, so this is Open Source Summit Europe by the Linux Foundation. And here we have on the left Linus Torvalds, and on the right, Dirk Handel, the head of open source program office at Verizon. Jesus. Okay. So let's let them talk and we'll do some commentary when it's appropriate.
Works for a very long time.
Yeah. Another topic on the kernel and that is creating a lot of conversation, let's say, is obviously Rust. And one of the maintainers stepped down last week saying, and I quote, non-technical nonsense as the reason for stepping down.
Sure.
And interestingly, there was quite a bit of argument, let's say, between the folks from Asahi working on the Apple Silicon GFX drivers and the DRM SCED people. So
Nerds
why is this
on
so
both
hard?
sides?
I think I actually enjoy it. I enjoy arguments. I think one of the nice parts about Rust has been how it's livened up some of the discussions. And I mean, some of the arguments get nasty and people do actually, decide this is not worth my time. But at the same time, it's kind of interesting and I think it shows how much people care. At the same time, I'm not quite sure why Rust has been such a contentious area. It reminds me of when I was young and people were arguing about VI versus Emacs.
They still are.
Maybe they still are.
Should we have a poll here in the room?
Yeah, no. But for some reason, the whole Rust versus C discussion has taken almost religious overtones in certain areas.
Well, so a big part of this is that from a design philosophy perspective, if you want to actually write memory-safe Rust code, there are certain architectural requirements. And it seems that a lot of the older, and I don't mean age, I mean just having been around for a longer time,
you mean age.
Maintainers are fairly resistant to accepting the fact that if you have a Rust subsystem, it requires you to have certain failure handling, which they don't want to add because they say, oh, that's a bug, that should never happen.
I mean, we have been doing this for over 3 decades, and C is, in the end, a very simple language. It's one of the reasons I enjoy C and why a lot of C programmers enjoy C, even if the other side of that picture is obviously that because it's simple, it's also very easy to make mistakes.
That's exactly what it is. It's too simple. It's too simple. The simplest problem I can think of is when you do pointers. Like, how comes that you can have a pointer to void and just cast that into any type that your imagination is capable of thinking? That's pretty dangerous.
And Rust is not. Rust is a very different thing, and there's a lot of people who are used to the C model, and they don't necessarily like the differences, and that's okay. In the kernel itself, almost nobody. I mean, I don't want to even say almost. Absolutely nobody understands everything in the kernel. I don't. I rely heavily on maintainers of various subsystems, and there are only a few areas where I get personally very much involved. And I think the same is true of Rust and C, is that you should expect that not everybody will understand Rust, and on the other hand, not all the Rust people necessarily understand C. And that's okay. I think it's actually one of the strengths we have in the kernel, that we can specialize, and some people care about drivers, and very specific drivers, and that some people care about specific architectures, and some people like file systems, and that's how it should be. And that's how I see Rust, but clearly there are people who just don't like the notion of Rust and having Rust encroach on their area. And I think it's been interesting, and I'm not afraid. I mean, people have even talked about the Rust integration being a failure. And I don't think, we've been doing this for a couple of years now, so it's way too early to even say that, but I also think even if it were to become a failure, and I don't think it will, that's how you learn. So I see the whole Rust thing as positive, even if the arguments are not necessarily always.
Yeah, and I mean, the challenge really is the idea that a memory-safe architecture makes certain assumptions about the infrastructure. And it's the infrastructure people, like the DRM-SCED as the example where it has become very public, it's the infrastructure people who seem to resist some of the changes.
To be fair, I mean, we've done a lot of changes to the C infrastructure too. The kind of code the kernel does is not normal C. We have, it's not just that we write things in a certain way, it's also that we have a lot of tools on the C side that enforce infrastructure rules that are not part of the language. And part of this is our locking safety. We do have actually a lot of memory safety infrastructure on the C side that is not technically part of C itself. It's part of our infrastructure for the kernel, where we have debug builds that make the kernel go much slower, but it will test a lot more of the memory safety stuff. So on the C side, though, we have been able to kind of incrementally add it. And I mean, we have a lot of that kind of support, but we've had a long time to add it. And that kind of has allowed people to do it without the outcry. And the Rust change is obviously a much bigger and much more in-your-face thing.
And so you said that...
And you have to respect the trade, meaning, can you imagine, well, we don't need to imagine. So this is a project that has been running for decades. Their tooling is super mature. Here comes a brand new language that doesn't use any of the tooling. And there's going to be friction. It's just part of the game. I think it's logical, and I applaud the Linux community for slowly but surely embracing Rust. And moreover, I think this is the perfect timing to give a huge shout out to the folks that made it happen. Rust, Linux, people. Oh yeah, because these exist because there are heroes out there making it happen. So I think here we'll find the main authors. Ojeda, this dude. Miguel Ojeda, huge leader making this happen. And I'm pretty sure that he's not alone. There's someone else. So Miguel Ojeda for sure. There's someone else. Let's look at the commit history. Marcus Grass for sure. And I'm sure that there are some others. Tom Stokes. And thank you guys for making it happen. I'm sure this is not easy. It's been a few years, but you are making it happen too. So you guys rock.
It's too early to say it's a failure, and I agree with that. But one of the things that I've seen lately is a certain amount of interest in bottoms-up, grown-up from the start Rust kernels as an alternative to Linux.
Yep.
So
you definitely need to. This is a problem I run into because many of my programs depend on libbpx or the Opus encoder, which are C libraries. So it does feel a little bit trashy that, yeah, you're creating a program using Rust, but the more powerful parts of the program are still C. It's just a fact. So let's see what Dirk has to say about like writing those underlying libraries in C, which, I mean, the most successful use case I can think of, or the most successful library will be rustls for encryption. So this is what I'm talking about. Crates.io. So rustls. Modern TLS library written in Rust. Oh man, this is great. So I think this is a very successful project that does not depend on OpenSSL. It stands on its own. And let's look at the cargo.toml here. Should be here, rustls, cargo.toml. It does not depend on OpenSSL. It doesn't depend on libc. This is a pure Rust project, which is great. Let me just look it up. Libc. There's no libc. There's no OpenSSL. So let's see where Dirk goes with this.
Is that a potential outcome if we continue to see struggle to get Rust into Linux, that there will be something like Redux or Maestro or one of the other ones that is popping up, that we will have an alternative universe built around the different kernel?
I think that's regardless of the Linux use of Rust. I think if you're doing operating systems, you really don't have very many choices when it comes to languages, because you require a language that can deal with system issues. And that automatically means that your language choices are very limited. Unless you want to write an assembler, you're going to use C or one of the C-like languages, or you're likely going to use Rust. And I don't think...
Facts.
I mean, Linux is not everywhere. And we're very widely spread, but after 3 decades, Linux is also very big, and we've always seen these embedded systems in particular who just want something smaller and simpler and not quite as fully fledged.
Yeah, I mean,
and that's when you would use Rust or C or anything else, and that will never go away, I think.
I mean, obviously we see things like Zephyr and other deeply embedded kernels, but as a general purpose OS, I think we can say Linux is absolutely everywhere.
Oh, yeah.
It's today, there is a complete Linux distribution running on most 5G modem chips. So in your iPhone is a chip that runs as its firmware Linux. So it is everywhere.
I mean, yes, we used to have this joke. I mean, many years ago, we used to talk about world domination. And that joke became reality and isn't funny anymore. So, and I'm okay with that. But at the same time, I mean, nothing lasts forever. And I'm sure some clueless young person will decide how hard can it be and start his own operating system in Rust or in something else. And if he keeps at it for many decades, or she, at many decades, hey, and I'm looking forward to seeing that.
To save you from bad quotes when you say some clueless person, that is a reflection on your own past.
Oh, absolutely. Yeah, you have to be all kinds of stupid to say, I can do this, right? Because it turns out, yes, I'm still doing it 33 years later, and I couldn't have done it without all the literally tens of thousands of other people anyway, and the only reason I ever started was that I didn't know how hard it would be. But that's what makes it fun.
Love it.
Right?
Yeah. So that is actually the perfect bridge to the next set of questions that I have.
Okay, so that's the segue to the next thing. So is that the whole problem that we're having here? Let me just look up, see if there's more drama, but this is not that. But this is, guys, if you work for a company, this is the real world. Let's see what they mean. Like, let's see, tension between C and Rust developers. And then they go over, oh, there you go, Miguel Ojeda. Oh, earlier this month, Miguel Ojeda wrote a message that he was removing himself as a maintainer of the Rust for Linux project. God damn it. I am retiring from the project. After almost 4 years, I find myself lacking the energy and enthusiasm so I once had to respond to some of the non-technical nonsense. So it's best to leave it up to those who still have it in them. This is so sad. To the Rust for Linux team, thank you, you're great. It was a pleasure working with y'all. The times we spent discussing technical issues, finding ways to address soundless holes were something I always enjoyed and looked forward to. I count myself lucky to have collaborated with such a talented and friendly group. I wish all the success to the project. I truly believe that the future of kernels is with memory-safe languages. I am no visionary, but if Linux doesn't internalize this, I'm afraid some other kernel will do to it what it did to Unix. And this is something that Linus himself hinted towards. Like, if we get the way I internalize this is, he said, like, if we get stuck on our ways and we don't want to change, then someone else will just write a new kernel, which is maybe what the industry needs. Linux is great, but if there are all these C zealots that don't want to move forward and are stuck on their ways, it's just capitalism. It's just the nature of humanity to find a way. Yeah, this is another example of code that probably will have to get rewritten if we were to move to Rust. Like all these pointer arithmetics, you cannot do any of this in Rust. Probably you'll have to find a way to use slices. That's the closest it gets to, because with slices we get our slices are the bounds of a slice are checked automatically. Here you're on your own, man. So I'm extremely sad and I cannot get over the fact that Miguel Ojeda is gone. But, well, it is what it is.